a sensor which measures the pressure, and it's a silicon based MEMS pressure sensor device. So MEMS stands for micro electromechanical systems. So morning you might have got more information about the introduction to MEMS and how does it work. Okay, so here we have two parts. One is the mechanical design and another is the electrical design. So we have the desired specifications, that's what we define, and then the methodology of the design, and piezoresistive pressure sensor principle is what we discussed, and then the design optimization can be so it involves mechanical and electrical modes. So desired specification. So we'll go ahead with this desired specification. We have the measurement mode, the absolute pressure. So we have two types. One is absolute pressure and one is the differential pressure sensor. So we are designing the absolute pressure sensor. And second is the operating range, which is about 50 bar. So 0.1 megapascal of pressure is equal to 1 bar of pressure. Okay, and we have the proof pressure, and which is set for 1.5 times the operating range, and the burst pressure of 5 times the operating range, and non-linearity is less than 0.5% full scale, and sensitivity is 10 millivolts per bar, and we have the full scale operation of hysteresis, base resistance as 2 kilo ohms. So keeping these as the desired specifications, how do we optimize or how do we design the device? Okay, that's what we'll be doing. So here, the MEMS pressure sensor transducer development methodology is start from MEMS pressure sensor design and fabrication, and signal conditioning, electronics, and PCB design and fabrication. Okay, so here we have the sensor which measures the signal, and we have the signal conditioning system which captures the signal provided by the MEMS pressure sensor, and then
Excuse me,
it
sir.
processes the signal.
Sripad, sir.
Yes.
Yeah, your voice is little bit low, sir. Can you adjust your
Oh,
mic?
is it? Oh, okay. Fine. Okay. Is it fine now?
Yeah, yes.
Is that fine now?
Yeah, yes, sir.
Okay. Yeah. Okay. So, and then we have the pressure sensor transducer assembly package component and the fabrication with electrical and mechanical interfaces, and testing is what we do. And then here we have the cycle of how the flow chart of how the user specification starts, and then how do we achieve the working model of the device. Okay, yeah, okay. And here we start with the user specifications and the sensor chip, and then we have the mask data preparation, sensor wafer fabrication. So this is what the method that we adopt. Okay, and here the pressure sensor as such has 4 resistors in principle, and 4 of them are connected in Wheatstone network mode. So typically we use a N-type silicon diaphragm with a P-type piezoresistors. So that's the trend. That's the technology that that's the materials that we adopt, and we have the piezoresistors are realized by selective doping. So we inject a boron into the diaphragm. So that's what is the piezoresistive P-type piezoresistor in an N-type substrate. Under no pressure condition, the Wheatstone network or the bridge is in the balanced condition. And when the pressure is applied to the bottom surface of the diaphragm, it undergoes a deflection, and which induces stress at the edges of the diaphragm. So let's look into each one of them. So when we go to the mechanical design optimization, we have the membrane design criteria. So here the membrane that we want to deflect due to the pressure that we apply uh, can be calculated using the Dmax formula. So this Dmax formula is used to find out for the applied pressure what is the maximum displacement that is happening. And for the stress that is developed. So we can see what is the maximum stress, the burst pressure also. So when we design them, naturally any device needs to meet some criteria. So criteria 1 is that the maximum deflection of the membrane should be less than 1/5 of the thickness. So this is criteria 1. And criteria 2 is proof pressure condition. The ratio of maximum deflection at proof pressure to the diaphragm thickness should be less than 0.5. And criteria 3 is the burst pressure condition, where the stress induced at the burst pressure should be less than the yield strength of the single crystal silicon. So based on all of these factors, we achieve or we come up with various design dimensions. And incidentally, we have an example for the design requirements which I shared in the beginning. So these dimensions of 720 micrometer by 1720 micrometer X and Y dimension and a 30 micrometer thickness of silicon diaphragm is a better choice. So using this, we will start designing them. So when we design them, so we can calculate these things using analytical methods. So for the applied pressure, so what we see is we get a Dmax, that is the maximum displacement at about 0.1 micrometer. Okay. And here on the other side, we have the electrical optimization. So the electrical resistance. Okay, let me talk about the piezoresistive part of it. So piezoresistive material as such is a material where when it increases its length, its resistivity changes. Okay, so due to the change in resistance, so we say we measure the change in voltage drop. So here, when there is a pressure that is applied, these piezoresistors expand. Due to that, there is a change in resistance for which there is a subsequent change in voltage. So, and these piezoresistors have something called as pi coefficients, pi 11, pi 12, pi 44. So these pi coefficients are responsible for this change in resistance. So here, what we do is we have N type where we we have a P type that we dope in a N type substrate. Okay, so why a P type piezoresistor? Because the orientation of maximum piezoresistivity in 110 direction of silicon for a 100 wafer happens to coincide with the edge orientation of conventionally etched diaphragm. Okay, so that's the reason why we use a P-type piezoresistor. And the stress distribution. So here, let me go come to this location. If you can recall the Wheatstone network that we have gone through, or what the basic fundamental circuit, we have 4 resistors which are 2 in parallel to each other. So R1 parallel R3 and R2 parallel R4. It's the same configuration that we have the 4 resistors. So these 4 resistors are mounted in this fashion. So you can see this diaphragm. So here we have R1 parallel R3, R2 parallel R4. So in this case, when we have a resistor mounted like this on the left side or on the right side, so we call that to be a longitudinal piezoresistor. Okay, and the one which is mounted on the top is called as a transverse piezoresistor. So why do we call longitudinal and transverse? Because in the figure below where you can see concentric circles, so when there is a pressure applied either from the top or from the bottom, so we see maximum displacement happening in the center. So when we look at the slope from the top view, you can draw concentric rings of the displacement that's happening. So the position of R1, the piezo resistor position of R1 experiences a stress in this direction. Okay, so you can see the arrow, it experiences a stress in transverse direction. Whereas in this one, the R2 and R3 experiences in, the longitudinal resistors experience stress in the longitudinal direction. So for this reason, it's called longitudinal resistor or transfer resistor. Okay, when this happens, there is a change in voltage, a change in resistance for which there will be a subsequent change in voltage drop. Okay, so we can calculate all of those resistance. So it's a general formula of rho L by A and the Ohm's law concepts. So we can calculate them. Okay, and then we measure the change in voltage. So now with the doping concentration, so we can see how the doping concentration can change the electrical conductivity and also the resistance. So here, when the doping concentration becomes high, naturally the resistance also goes low. So we need to have a better doping concentration to achieve a better result, better yield. Okay, so for that we need to look at a better doping concentration for piezoresistors. Okay, so here when we fabricate the device, it looks like this. So the center blue line, blue part, the center point of the diagram, so that's the overall sensor. Okay, whereas these 8-pin dual inline package is what the device that we get on hand. Okay, so this is how it looks like. So these are the pin configurations. Okay, and that's how it has been packaged, so we can fabricate it. So this is just an overview for you to make you understand about what you will be trying to design now using the video tutorial. Okay, so this is what it is. So now I'll be sharing my a video where you get access to that file and you can download or you can see it online and you can follow the instructions. And those who have got the access, I hope the installation is all done. Okay, and the software is working fine using the standard steps which was shared yesterday. Okay, so I'll be sharing my link so you can take a look at it. Is anyone having any issue opening the software? You can report it.
Participants,
So
I am just unmuting them. You can discuss with them.
yes, yeah. So all of your mic are you'll be able to unmute your mic. So those who wish to get clarified on the software installation, so you can just let me know. Or else you can drop in a message also in case if you have any issues. Yeah, so you can free to unmute your mic if you wish to speak.
Can you
Sir,
once you can able to explain online
software
also?
how to open it, sir? We have installed over there.
It has been installed, right?
Yeah, installed correctly.
Okay, so the software, if it is installed, so then on your desktop screen, there will be a folder called Intellisuite. Okay. So on your screen.
Yeah, that is there.
Yes.
Yes, sir. That is there.
Okay. Okay. Yeah. So fine. So so on your desktop screen. Okay, I repeat from the beginning. Those who have installed the software and have got the license, if you have completed the installation as per the instruction given in the video tutorial, you will see a folder called Intellisuite on your desktop. Okay, you can open that folder. You will see multiple modules.
So from where to get that software, please?
Okay, so actually, there was an email that was sent about 10 days ago for those who have registered for the workshop for to avail the software. So I think few of them have registered to get the license. They shared their PC details. So those who have shared the PC details, the license has been given to them. Okay. Yeah. So here I have shared a link. You can click on that link. So that will give you an access to one of the video tutorial,
Okay.
and then you can follow the instructions. Johannes, you have not received any email regarding the license. If okay, yeah, okay. So there were three. What I understand from my colleague is there were three people who had. I mean, the PC details were not really genuine, is what our system felt. So that's what the license was not issued. Okay, so those three people will be contacted, and then the license will be given to them later today. Okay. So were you are you able to see the video in the link that is provided?
Yes, sir. Yes, sir. Video is
Okay,
there.
great. Yes. Okay. So you keep your mic in mute mode only. Okay. Uh, I request Dr. Vasu not to lock their mic. Okay, but I also request other participants to keep your mic in mute only. Okay, those who wish to interact or have any questions can unmute your mic, and then you can raise the question. In case if there is any situation where we need to see the screen, then at that time we will see how to see your screen also, so that you can share your screen and we can resolve this. Okay, so right now follow the video tutorial, and you can repeat and do the simulation, design and simulation. So the video tutorial contains two parts. One is the design using the fabrication process flow, and another is the simulation part of it. So you can continue. Okay, any questions you can always ping, so we can discuss. I am available throughout the meeting.
Sripad sir, how much time it will take, sir, that for you to simulate that fully?
Sir, my personal feeling, which we have done earlier, we take at least minimum 2 hours to design and simulate it. They need to follow that instructions. So many are new to the tool, so naturally they will take some time.
You can also share your screen and tell like that also.
No, I deliberately did this because everyone does the job in their own pace. Okay, so some may move fast, some may be a little slower. So on their pace, they can do it. Okay, so what I can also do is I can give you the video file. Uh, okay, and you can include it in your session.
Okay. Okay.
Yeah.
I think some people have lately joined. For them, I think they have not entered the PC details. For them, they did not got software. I think so. The people for them, if any help is there, you can help, sir.
Yeah, so tomorrow also we have a session. So those who did not register before 30th of June, I'll share the link so you can register your PC details and then you can get the access.
Am I audible? Hello.
Yes,
Hello.
we can hear you.
Sir, I
Yes.
have given the PC details, sir, but I have not received any mail regarding the software installation or anything.
Yeah. See, I understand, but uh, so those people who registered before 30th June, those I think we had given a deadline
Yes, sir.
before
Before
30th June.
30th only I have given. Before 30th I
Your
have given.
name, sorry, your name.
Chinmay, sir. Chinmay Sahu.
Okay.
In
Okay.
29th
So
only
let
I
me.
have given the PC details,
Yes.
but I have
Yes.
not received
20.
any mail regarding the installation or instructions for the installation of the
Or is it?
software.
Okay. Yeah. I think today, I think it will be resolved. But anyways, the license that is being given is valid for 1 week, this week. Okay. So
Okay.
the link, the video tutorial is also available for you. Okay.
Okay.
So, yeah.
In that
So
video,
you can.
tutorial only installation things are there. How to install, how
Yeah.
to
No. No.
get the software.
Installation things and all will be shared by my other colleague. Okay.
Okay. Till now
Yeah.
we have not. I have not got any mails regarding that, sir.
Okay, fine. So those people who have not received it, I think, yeah, so we'll contact you. Okay. So those people who have registered, there are people who have registered after 30th June. So naturally they have not got it. We are sure because we had to send the request to US and then get the license. So we put a deadline of 30th June. Okay. So for 6 people who have registered after July 1st, I think license can be given later today. Okay, so everything's going well. Any problem, any issues, you can always share your screen and then we can resolve it. Okay. Dr. Chinmay Sahu, I have shared the link below. You can follow that tutorial to perform the installation.
Okay. Thank you, sir. Thank you.
Okay.
People who are not having that all, they can also follow that one, sir. The people who are not having software
Yes,
license, they can
they
follow
can
that
follow
link.
that. Correct. Yes. So that's the installation instruction. So those who wish to do not have the software access can watch the video, and that video access is also available to you with the license till end of this week. So you can always do it at your convenience also, and then even tomorrow we can discuss the same. So in case if you are able, if you are done by today, and if you want to learn more, so we can also discuss one more example of a MEMS accelerometer tomorrow. So we have a choice. Okay, it's not just one device. We can also learn two devices. Today, piezoresistive pressure sensor, and tomorrow we can uh, learn the accelerometer.
Excuse me, sir. Where we have to download the software, sir? Hello.
You have to
Where?
download it now.
Yeah, I have not downloaded it.
Oh, okay, okay, yeah.
Actually,
So
no information I got to how to download or anything I got. I have not got anywhere
yeah,
in
true,
my
true.
mail.
I understand. But did you provide your PC details sometime?
Yes, sir. Before 29 only I have given the PC details.
Sorry, your name?
Chinmay Sahu.
Yeah, I think I'm not too sure because I don't handle these things. So this coordination will be done by some my other person. Okay. So, but anyways, if you want to download it, I think I can give an access.
Okay. Please give, sir.
Yeah. Okay.
Anyhow, I have to utilize the time now. now.
Yeah, that is right. That is right.
Yes, sir. Okay. Thank you.
Anyways, so even post 6 also, post 6 o'clock also, you can continue. It's anyways, it's a video tutorial, so you can do it at your convenience also.
Okay. Thank you. Thank you, sir. Thank you.
Yeah. Okay.